Welcome back to our today's lesson. I hope you're well. Today I want us to look at this most asked topic. It's about the format of the Kcse chemistry examination, and I want to break it down in a way that we will have a series of topics about it. Kcse chemistry examination have at least 3 questions, and we have question 1 and 2, which can either be on titration, enthalpy change, solubility, or reaction rates. Question 3 is usually on qualitative analysis. Then down here we have the areas examined at Kcse chemistry practicals, which are usually from organic chemistry, quantitative analysis, qualitative analysis, solubility, energy changes in chemical and physical processes, and also reaction rates. So if today you want to revise on chemistry practicals, those are the areas that you need to revise on. I'll be guiding you on step-by-step way of understanding each and every part of it, and at the end of the series, you'll be in a position to do the chemistry practical and end up achieving your goal. So welcome as we move on. So we begin. I prefer that you take a book and a pen, sit back and take good notes. You will need them in the near future. So we begin in questions 1 and 2. That, as I said earlier on, are either on titration, enthalpy change, solubility, or reaction rates. The following areas are tested. So in other words, I'm showing you where to get marks from. And this is serious. You need to take good notes. A, we have completion of tables, meaning you'll get a table either on titration, enthalpy change, on solubility, or on reaction rates. NB, about any table that you get. All tables must be, the word is must. Underline that word must. All tables must be completed with realistic values. Underline the words realistic values. What does that mean? For example, in a burette, the values run from 0 to 50. If you're filling a table on titration, then you should not have a value like 50.1. Where did you get the 0.1 from? So realistic values. Only those values that are within whatever apparatus that you're using. The apparatus in this case include the burette, the pipettes, the thermometers. So you read from where the values starts or where they begin to where they end. You should not have a lower value or a bigger value than whatever you have in your the apparatus that you've been provided for. I'll be guiding you more on the same as we move on. Next, we have the use of decimals. In titration, use of 1 decimal is recommended. In KRB Book 3, it is also said that you can use 2 decimals. But through experience, I would advise you as a learner to only use 1 decimal. Reason, when you're reading a burette, it is very easy for you to read the values when it is to 1 decimal place. But when it goes to 2 decimal places, you'll not be accurate. You won't. So I recommend to you to be on the safer side, use 1 decimal place. And when you decide to use that 1 decimal place, let it be throughout the table. No single value should have any other decimal point other than 1 decimal point. Like you should not have a mixture of 1 decimal point, other values have 2 decimal points. No. You should also not have a mixture of 1 decimal points, 2 decimal points, whole numbers. It is 1 decimal point throughout. And the 1 decimal point is either a 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, or 0.9. For example, if your reading are between 20 and 21, you can have 20.1, 20.5, 20.2, 20.9, etc. So the thing is, 1 decimal place recommended to you by me, and you should have it throughout the table. A mixture of more than 1 type of a decimal place finds you on a penalty. Then from there we go to another major point that I have forgotten. In addition to the decimal points that I have provided, we can also have a 0.0. For example, 20.0. So do not forget that. Do not get confused. The decimal points can be a 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, or 0.9. The second point, for temperatures, because in question 1 and 2, we can also have a practical that requires us to take data dealing with temperatures. So for temperatures, only 1 decimal point is used. So here we do not have a provision of 2 decimal points. Only 1 decimal point can be used. And this 1 decimal point can only be a 0.0 or a 0.5. For example, you can have 19.0 or 19.5. That is just an example. That means there are no values like 19.1, no values like 19.2, no values like 20.8. It can only be a 0.0 or a 0.5. 0.0 or a 0.5. Strictly that. Any other will be a wrong value and it will not be marked right. The other thing that is looked at in questions 1 and 2 is about accuracy. Accuracy. So for you to achieve accuracy, you just need to follow all the instructions carefully. And where do you get all these instructions from? They are the instructions provided in the procedures that are provided in the question. And once you follow all these instructions carefully, you should then be careful when recording your data. Remember, you can be very keen in following instructions, but fail when you record your data in the wrong way. So there are two things here. One is you follow all the instructions very carefully from the procedure provided. And then once you follow it carefully, record your data accurately. Because no one will know if you follow the instructions carefully, if your data is recorded inaccurately or not accurately. The other thing that we look at is the principles of averaging. One common question that requires you to average is titration. So the values to be averaged, e.g. in a titration question, are only those values that are within plus or minus 0.1 or plus or minus 0.2 difference from one value to the other. So next I'll be providing you a table as an example so that you and I can assist each other in knowing from the table that I'll provide which values can be averaged and which ones cannot be averaged. So keep it right there. I hope you're still writing your notes. Do not forget to write your notes. Underline the major points where you can. And this is just a beginning towards you getting the best chemistry grade ever. So keep it right there. Keep on writing your notes. They are there in case of anything. Ask in the comment section.